First, we will discuss the derivative of inverse functions. So first, I'll just explain to you what you mean by inverse function. Then we'll talk about what happens when you take the derivative of an inverse function and when you take a derivative of a function. First of all, let's look at the function f of x equal to, let's say, 2x plus 1. What is this function? Let's have a look at it. This is the value of x. This is the value of y. Let's put some values here. X is 0, 1, 2, 3, 4. When I put x as 0, corresponding value of y is 1. We write it as f of 0 is 1. When I put x as 1 here, corresponding value is 3. We write it as f of 1 is 3. If I put x as 2, the corresponding value will be 5. So we write f of 2 as 5 and goes on like that. 3 when I put it as 7, 4 I put it as 9. Now I'm going to define another function, let's say g of x. It is defined as x minus 1 divided by 2. Here, the set A, let's see what is the set A and B. This set I am denoting by B and this set I am denoting by A. When I put B as 1, 3, 5, 7, 9, what is happening? When I replace x by 1, I get 0. So 1 is related to 0. When I put x as 3, it is related to 1. 5 is related to 2. 7 is related to 3. 9 is related to 4. 9 minus 1 divided by 2, 4. If you compare this both function, what do you notice? Whatever the x coordinate here, and if you write this way, one more thing I forgot. G of 1 is 0. G of 3 is 1. G of 5 is 2 and goes on like that. If you look at this, here 0 is related to 1 and here 1 is related to 0. So what do you notice here? X coordinate and y coordinate are getting interchanged. We say that f is the inverse of g, the function f is inverse of g, as well as g is the inverse of f. One important thing to notice, if 0, 1 belongs to f, then 1, 0 will belong to g. Then g will be the inverse function of f and f will be the inverse function of g, for not for one element, for all the elements it should happen that way. Which we write it as g is the inverse of f. The function g is the inverse of f. We write it as g is equal to f inverse. Don't read it as f raised to minus 1. Read it as f inverse. We can also say that g inverse is f. Both ways that's correct. So we usually write it f inverse of x. So I can say like this. If f of x equal to, if f of x equal to y is equal to f of x, then the g can be denoted as f inverse x. That is, here f of x is 2x plus 1. Y is obtained by using this formula. So y equal to f of x. And f inverse of x is x minus 1 upon 2. So to calculate an inverse of a function, I am going to teach it now further. How did I get this? What is the method of obtaining an inverse function? So method of obtaining an inverse function is very simple method. If you compare this both, what is actually happening? The y coordinate and x coordinate are getting interchanged. So you start with this function y equal to 2x plus 1. Make x as a subject. Y minus 1 upon 2. This can be written as, if you ask me, the notation for this is y equal to fx. Notation for this is x equal to f inverse y. And if you ask me what is y equal to f of x, f inverse of x, then what you have to do is, wherever x is there, put y, and wherever y is there, put x. So this is how 3 notations we have to learn. Given notation, y equal to f of x. In that, y is a subject. If you want to make x as a subject, if I want to say make x as a subject, I should say x equal to f inverse y. I want to write the inverse function of this. Then what I should do? X will become y and y will become x. You will get the inverse function. Once again, to calculate x is equal to f inverse y, what should I do? make x as a subject. So first question is calculate f(x) equal to f inverse y. Whatever the function given to you, make x as a subject, you will get f inverse y. Then to calculate y equal to f inverse x you replace by y and y you replace by x, you will get a new function. This new function is the inverse of the original function. That's how you get this formula. You can see f of x is 2x plus 1. G of x is x minus 1 upon 2. So how did I get this x minus 1 upon 2? I made x as a subject and then replace x by y and y by x. You will get the inverse of the function. Now let's practice few problems on this. We will just understand all the three notation by using examples. Let's say I have a function y is root of 1 minus root x. I want to convert it into x is equal to f inverse format. What I should do? First I will make, that means what does this mean? Make x as a subject. First I'll make root x as a subject. Square both the side, 1 minus root x. Make root x as a subject, 1 minus y square. Make x as a subject, square both the side. So I can write x is equal to 1 minus y square the whole square. Now I want to write the inverse function of this. So I need inverse function. So f inverse is defined as this formula. What is the formula? 1 minus square of the subject, the whole square. So y becomes, in this, what is y? It will become x here. Whatever y, it will become x here. So in place of this x, you will have y. In place of y, you will have x. So I can say if y is equal to f of x is this, then its inverse function is y equal to 1 minus x square the whole square. For example, if I put x as 4, x as 0. If I put x as 0 here, I'll get y as 1. Now, if I put x as 1 here, I'll get y as 0. Which means, if in this a comma b is a point in it, in this b comma a is a point on it. That means every x coordinate and y coordinate get interchanged by this formula. Therefore, this is called the inverse function of this. So we write it as f inverse of x. Let's try one more problem. A few more problems we'll try. Another example I want to give you. Let's say I have y equal to log x. Log x to base 2. Now, how to make x as a subject? You know that log x to the base 2, if you want to make x as a subject, x is 2 raised to y. The meaning of log x is what is the value of y to get x as 2 raised to y as x. So that is x if you want to make it subject, 2 raised to y. In logarithm chapter we have learned this. Now make as a function, this is f of x, its inverse function. So y equal to 2 raised to x. So what did I do? X ke place mein y or y ke jagah pe x. So this is the inverse function of x. So I can say if f of x is log x to the base 2, what is this inverse function f inverse x? Is 2 raised to x. So they are inverse function of each other. Now one beautiful thing I'm going to show you. If I calculate f of f inverse x, let's see what will happen. You know that f of x is log x to the base 2 and f inverse is 2 raised to x. So I'm going to replace this by 2 raised to x. Now what does f of 2 raised to x means? Where in the formula, wherever x is there, replace it by 2 raised to x. In the formula of f of x, wherever x is there, replace it by 2 minus x is over here. So replace by 2 minus x. Which can be written as x log 2 to the base 2. Log 2 to the base 2 is 1. So what you notice, f of f inverse x is x. So whenever you find a composite function of a function and its inverse, you will end up in x. Very, very important. So I can say like this. This is one of the property of inverse function. If g is inverse of f, if g is the inverse function of f, so g is the inverse of f. That means g of x is f inverse of x. Now transfer this to left hand side. F of gx equal to x. This is very, very important. See the method? Given to you, g is inverse of f. So I can write g is equal to f inverse x. That means the formula of g of x, f inverse of x, they both are equal. then what you can say? This f you bring it to left hand side. So f of gx equal to x. So this notation will help you out all the time. What I showed you is the same thing. F of its inverse will always give you x as the answer. Then this is a property, one of the most important property that you should remember. So what are things I've taught you? If y is equal to fx, how to make x as a subject and write f inverse of y. Then how to find the inverse of the subject. Then what I showed you. If you take the composite function f of f inverse x, you will end up in x. These are the most important thing. Second thing to remember, as I told you, if 3, 4 belongs to f, then 4, 3 will belong to f inverse. For how many points? All the points. Every point this should happen. If a, b belongs to f, then b, a should belong to f inverse. Then only one function becomes the inverse of the other. That is the definition of inverse of the function. So these are the points to remember. Let's practice one more problem. Let's say y is equal to 10 raised to x. Now make x as a subject, x as a subject. So take log on both the sides. Log y is log 10 raised to x. So what the base of the log I'm going to take? 10. So that I want to get cancelled. So log y to the base 10 is x log 10 to the base 10, which is nothing but x. So x is equal to log y to the base 10. So what will be the inverse function? What will be the inverse function? Y is equal to log x to the base 10. So you have learned logarithm is the inverse of exponential and exponential is the inverse of the logarithm. So they both are inverse of each other. If the base of exponential is 2, then inverse will have log also to have base 2. That's why this is a relationship between inverse function, exponential function and logarithmic function. They are inverse function of each other. Now let's take one more example. Suppose I have given to you y is equal to log of 2x plus 1 to the base 3. Now make x as a subject. How to make x as a subject? 3 will become the base of y. 3 raised to y is 2x plus 1. Now make x as a subject here. X equal to 3 raised to y minus 1 upon 2. So I can write x is equal to 3 raised to y minus 1 upon 2. So I can write the inverse function of this will be y is equal to 3 raised to x minus 1 upon 2. These are the inverse function. Now what I am going to do next is I am going to compare the derivative of both of them. A function and its inverse function's derivative. Let's have a look at it. So let me take this example and notice what is happening here. If I calculate dy by dx, I'll get 1 upon 2 root 1 minus root x into derivative of 1 minus root x, so minus 1 upon 2 root x. So I can write minus 1 upon 4 root 1 minus root x into root x. Now let me differentiate this and say, I'm differentiating here, the function is in x, and what you differentiated? You differentiated y. Now the function is in x, the function is in y, so we are differentiating with respect to y, dx by dy. What will be my answer? 2 into 1 minus y square into derivative of 1 minus y square, so minus 2y. They are differentiated with respect to y, so y square derivative minus. So minus 4 into 1 minus y square into y. Now you know that y is root of 1 minus root x. So since I want to compare both of them, either I have to make everything in y or everything in x. So let me make everything in x. Minus 4 into 1 minus y square, if you square this, 1 minus root x. Y root of 1 minus root x. So this will become minus 4 root x into root of 1 minus root x. What did you notice? Let's look at this both. You can see they are reciprocal of each other, which means if I differentiate y with respect to x and if I differentiate x with respect to y, I will notice that they will be reciprocal of each other. So dy by dx and will be 1 upon dx by dy. That is, y is a function of x. Make x as a subject. Differentiate y. Differentiate x with respect to y. Here, differentiate y with respect to x. Differentiate here, x with respect to y. You will notice that one of them will be reciprocal of the other. So whenever I want to find derivative of the inverse function, I can always do this method. What I should do? Whichever you can differentiate. Suppose this is easy to differentiate. Differentiate that and then take the reciprocal. You will get the derivative of the inverse function. But the only thing is, x will be in terms of y and y will be in terms of x. That means if I want to find dy by dx, I need to only just interchange the variables. Then I will get dy by dx. Let's have a look at what happens here. If I calculate dy by dx here, this will become 2 into 1 minus x square into minus 2x. And you can notice that this is minus 4x into 1 minus x square. Compare this both. What is the change? In place of y, x. In place of x, y. So if I want to find derivative of inverse function, make x as a subject, find the derivative, replace x by y and y by x, I'll get the derivative of the inverse function. So what all things I've done here? I will write this as d by dx of f inverse x. This is d by dy of f inverse y. So both of them will be same. If you replace y by x, you will get this. So if you differentiate y with respect to x, so that means this is nothing but d by dx of f of x. So d by dx of f of x, d by dy of f inverse x will be reciprocal of each other. So if I want to calculate derivative of the inverse function, what should I do? Take the function, differentiate it, take the reciprocal, replace x by y and y by x, I'll get the derivative of the inverse function. Derivative of a function using its inverse function. So first we will generate, this is a function given to you, we will generate its inverse function. So how to generate its inverse function? That means make x as a subject. So I can see y square is equal to 2 minus root x. So root x equal to 2 minus y square. Squaring it, 2 minus y square the whole square. So I write here x equal to 2 minus y square the whole square. 2 minus y square the whole square. Now after finding out the x as a subject, that means I have calculated its inverse function. Now I'll calculate its derivative, dx by dy. What will be the derivative of this? It will be 2 into 2 minus y square into derivative of 2 minus y square, so minus 2y. So my answer would be minus 4y into 2 minus y square. Now we know that derivative of y with respect to x, this derivative of this function is reciprocal of this. So I can write dy by dx is 1 upon minus 4y into 2 minus y square. Now finally, you usually write the answer in x. So you want the derivative of the inverse function, derivative of the function in terms of x, not in terms of y. So what we'll do? Wherever y is there, we'll replace it by using this. So your answer will be 1 upon minus 4 into, what is y? Root of 2 minus root x. Then what is 2 minus y square? 2 minus y square is root x, and that will be my answer. So wherever y is there, replace it by root of 2 minus root x. Wherever 2 minus y square was there, 2 minus y square we had already calculated it, so I'll directly replace it by root x. Or in other words, just remove all the y by using the given function. You will get the derivative. Now check whether they both are equal or not. Let's check whether the derivatives are equal or not. What will be the derivative of y? 1 by 2 root 2 minus root x into derivative of 2 minus root x. So minus 1 upon 2 root x. You can see exactly the same answer that you have got over here. So this is a way to find out derivative by using the inverse function. Once again, first of all, start with a function. I don't want to directly differentiate and get the answer. This method I don't want. What I'll do? First make x as a subject. Differentiate with respect to y. Then derivative of y would be reciprocal of it. Then change y to x using the original function. Using the original function, convert y to x, you get your answer. Where you use this maximum is when I want to find the derivative of inverse trigonometric function. Suppose I want to find the derivative of sine inverse x. I do not know the formula for y is equal to sine inverse x. What I'll do? I'll make x as a subject. I'll make x as a subject. Then I will differentiate with respect to y. I'll get cos y. Then I will find out the derivative, but I need the derivative of y with respect to x. I need the derivative of y with respect to x. So it will become 1 upon cos y. Now I need to convert this cos y to x. What does x stands for? Sin y. So I will write this as 1 upon root of 1 minus sin square y. We know that cos square theta is 1 minus sin square theta. And I get the answer root of 1 minus x square. This is the benefit of learning this. Why do you learn this is, all these functions can be directly differentiated and obtained. But there are functions, for example, sin inverse x. I do not know how to find the derivative. So what is the method I adopted? I made x as a subject. Then what I did? Differentiated with respect to y. And we know that derivative of the inverse function and derivative of the function are reciprocal. So I took the reciprocal. After taking the reciprocal, this is the most important step. What is that? Convert it back to x. But how do you convert back to x? Go to the original function. What is x? Sin y. So convert cos y to sin y, then sin y to x. That's how you convert back to the original function. This I just give an example, but we will practice more without this. This I will be taking as a next module. But just to get the whole idea, I will explain to you this. Given f of x is x square minus x minus 2 for x greater than or equal to half. While this condition is given, then only its inverse function will be defined. Okay, we want to find the derivative of inverse function at x equal to 4, which means we have one function y equal to f of x. Another function we have y is equal to f inverse x. We are supposed to calculate the derivative of f inverse x. And then the x coordinate is 4 here. We are supposed to calculate at x equal to 4. This is how we are supposed to do it. But the problem is we cannot calculate the inverse function of this. It's very difficult to calculate the inverse function. So using derivative of f of x, we need to calculate the derivative of f inverse x. So you know that dy by dx is 1 upon dx by dy. We can apply that. But one problem is there. Here x coordinate is 4. And you know that in the function it gets interchanged. That means y will be 4 and what is x? So you will put y coordinate as 4 and obtain x. So 4 is equal to x square minus x minus 2. So x square minus x minus 6 equal to 0. So x minus 3 into x plus 2 equal to 0. So x equal to 3 and x equal to minus 2. But this does not belong to the domain because x is always greater than or equal to half. So x equal to 3. That means the y coordinate here, this point corresponds to 3, 4. So the point here will corresponds to 4, 3. That means here when x is 3, y is 4. Here when y is 4, x is 3. So we can calculate derivative of x equal to 4 by differentiating this function. So let's have a look now. So what I have got now? I have dy by dx. Dy by dx will be 2x minus 1. Dy by dx at x equal to 3 will be 2 into 3 minus 1, which will give me the answer as 5. So derivative of f inverse of x when x takes value 4, when x takes value 4, when x takes value 4, when x takes value 3, y takes value 4 in the function, so its inverse function will get reversed, will be 1 upon 5. The derivative here is 5. So derivative here will be 1 by 5. They will be reciprocal of each other. The coordinate of x here, 3, will become an inverse function. The y coordinate corresponded to x equal to 3. That's why this becomes x equal to 4. Although derivative has to be just inversed, but the coordinate here will get reversed. What is y coordinate here? Will become x coordinate over here. So what is given to you? In inverse function, when x becomes 4, what is the derivative? So when x becomes 4 in the inverse function, y will become 3 there. So x will become 3 in the function. X will become 3 in the function. So you need to calculate derivative at x equal to 3 and take the reciprocal. You will get the derivative when x equal to 4 in the inverse function. So x coordinate, y coordinate get interchanged. That's why we have to do that. So what is the method? First put y as 4 in the given function. Get the corresponding x coordinate. Whatever you get by the reciprocal of the derivative is the derivative of the inverse function at that point where x became 3 y coordinate became 4. So at 4, the derivative will be the reciprocal. If y is equal to root x, find f inverse derivative at 2. So when y is 2, 2 is equal to root x, so x equal to 4. So the point corresponding to this function is 4, 2. So what is the derivative? dy by dx is 1 by root x, 1 by 2 root x. So dy by dx at x equal to 4 is 1 by 2 root 4, that is 1 by 4. So derivative of the inverse function at x equal to how much? Not 4. At x equal to 2 will be 4. That is my answer. So first you need to know the coordinate. So how to calculate the derivative at 2? So you will put y as 2, get the x coordinate, use that x coordinate and get the derivative of the function. Take the reciprocal of this value, you will get the derivative at 2. Given to you the function y equal to log x to the base e, find f inverse of 1, derivative at f inverse 1, or derivative of the function derivative of the f inverse function when x takes value 1. This is a question. That's the meaning of f inverse 1's derivative. Or you can say like this, f inverse prime 1. And this both means the same thing. So what we do is, first we find what does this 1 stands for? 1 stands for the y coordinate of the function. So when y is 1, what will be the value of x? So 1 is equal to log x to the base e. So x will be e. So the point in this is e comma 1. What is the derivative dy by dx? 1 by x. So what will be the derivative at x equal to e is 1 by e. So what you can say from here? Derivative of f inverse of x at x equal to how much? Not at x equal to e. At x equal to 1 will be the reciprocal of this. That will be e. Now I'll show you this to make you, I feel that you may be confused here. To make you understand this, let me draw the graph. First of all, the inverse function of this is e raised to x. The inverse function of this is e raised to x. What will be the derivative of e raised to x? E raised to x only. Derivative of e raised to x equal to 1, how much will be? E. You can see both are tallying. Or to understand a little more, let's say this is a graph of y equal to log x. And this is a graph of y equal to e raised to x. We know the derivative at e comma 1. Then you can calculate the derivative of this function at 1 comma e. If you know the derivative of the function at e comma 1, then the derivative of the inverse function at 1 comma e will be reciprocal. So the slope of the derivative here is 1 by e. So derivative over here will be e. That is the meaning of it. Here the function is x square plus 3 for x greater than 0. Find the derivative of the f inverse at x is 4. So we are given the x coordinate of the inverse function is 4. So y coordinate of the function is 4. That means 4 is equal to x square plus 3. So x square is 1. So x is plus or minus 1. But x is a positive number. So x does not belong to, x is not equal to minus 1. So x can be only 1. So the point corresponding to this is 1 comma 4. So what I'll do first, I'll find the derivative at 1. So derivative here is 2x, that is 2 into 1, which gives me 2 answer. Hence the answer of this f dash of f inverse derivative at 4 will be 1 by 2. So whatever the derivative at x equal to 1 will be the derivative at 4 in case of the inverse function. So the point that is given to you is a y coordinate. Calculate the corresponding x coordinate, find the derivative at that point, and its reciprocal is the derivative